Hi, I'm Pat Forster with the STS-117 crew, and you're watching NASA TV.
Atlantis, Houston on air to ground 2 for EPS.
Houston, go ahead for Atlantis.
Hey, Brew, just want to point your attention to message 61 Alpha. We'd like you to put that in work, and what that's going to do, it's a modified power down, and it's going to hopefully give us an extra dock day based on the attitude problems we've had.
Okay, Shane, I will go look for 61 Alpha. Thank you very much.
We're just trying to maybe buy some margin with an extra dock day. I'm certainly not giving you a go-ahead for another dock day.
We fully understand, Shane, and we understand why you're doing this and what the reasons are for it. We're happy to do it.
Okay, great. Thanks, Brew.
With that message from spacecraft communicator Shane Kimbrough, Mission Control in Houston has given the shuttle crew the go to implement what is called a modified Group C power down. That plan to further reduce systems that are operating on board the shuttle and is designed to save shuttle supplies, shuttle cryogenics that generate electricity in order to be able, if necessary, to keep the shuttle at the station a day longer than is currently planned. That plan was developed during the planning shift early this morning and was being done while in parallel while the Russian mission control teams were working to restore operation of computers in the Russian segment of the station. Those computers were, among other things, the ones that commanded the Russian thrusters, which are the secondary attitude control system for the International Space Station. While the Russian computers were down, it would not have been possible to command to the Russian thrusters. And so as a backup, the shuttle team worked up a plan for the shuttle crew members to be able to power off some non-critical systems in order to save power. And despite the fact that the Russian computers, both the central computer and the terminal computer, have been restarted, at least on one lane each, one redundant lane each, the decision's been made to have the crew go ahead and implement that modified Group C power down now to begin to build additional margin. The decision has not been made at this point to ask the shuttle to remain at the station longer than is currently planned.
On the big loop, the sun is up. We're ready to do the 2B retract. So on 3, we'll retract. 1, 2, 3, retract. Abort. Houston, Atlantis on the big loop. The first bay looked pretty good. We're just double checking our, we're getting ready to arm for a second bay retraction.
Copy, Sonny, and we're checking.
Houston, Atlantis on the big loop, ready to retract one more bay on 3. 1, 2, 3, retract. Abort.
Houston, Atlantis for solar race.
Go ahead, CJ.
Yeah, I know you probably got the sun right in your cameras like we do, but that looked really good. It definitely fixed the outer part of the left blanket box. And just on the inner part of the left blanket box, you can see we're just looking at that area of interest right at the bottom. And we'll take a look at that for a few minutes and see if there's anything, but we'll call you back if I think we'll be ready to proceed if you're happy.
ISS Houston on the big loop for the retract. We're looking at the blanket box, and based on what we see, we're going to implement a wiggle.
Yep, we've got a slack guide wire there, Houston, so that wiggle sounds like a good plan.
Thanks, DJ. We'll put that in mark now.
The Falcon console, the solar array wing experts in the station flight control room will command the beta gimbal assembly at the base of the solar array wing to rotate a few degrees to impart a wiggle or a motion on the panels to help free up any guide wires the crew on board indicated may be pointing in the wrong direction or not assisting with the panels being folded correctly. The ground team also monitoring any of the panels billowing out of plane as they're being pulled down towards the blanket boxes.
ISS Houston on the big loop for the retract. The wiggle is now complete if you give us the status on the cable.
Okay, we didn't get to see the wiggle, but it's still the same way, Steve, and we're going to need to. I think this is a time to consider a re-extending. I definitely would not retract anymore in this configuration. And the cable still has a loop in it, and the sun is not good right now. I would say it's at least 6 inches and maybe 8 inches of slack guide wire.
Copy, CJ, and we will implement a 2-second deploy.
Okay, I understand. You're going to deploy for 2 seconds?
That's correct.
All right, we're watching.
And CJ, the 2-second deploy is complete, if you want to take a look.
And Houston, on that inner guide wire on the left blanket box, now you can see, because of the extension, you can see there were actually 2 loops. They probably were there the whole time, but one of them was in shadowing. So I would say that there's a good bit of slack guide wire, more than I reported on the first time. I can see 2 loops, so that must be at least... it'd be more than a foot total.
Thanks.
And Houston, I definitely would, let's hold off on any more extensions or retractions till we can look at this a little better. I think we may be, we'll provide a recommendation in a few minutes.
Thanks, CJ, and we'll hold.
Houston, Atlantis on a big loop.
Go ahead, CJ.
Great news. The wire just freed itself. I was just photo mapping it with the 800 to send you some more pictures, and Brew was looking through the binoculars, so we both saw it. The guide wire, it just popped and it sucked in all the loose wire there, so it's all good.
That is great to hear, CJ.
Houston, Atlantis on a big loop for solar arrays.
Go ahead, CJ, for solar arrays.
Megan, we're just trying to look ahead and plan what we're doing up here, and I was wondering if you could give us some insight, if you got the pictures, and if you are expecting to get any news or a plan of action during this insulation pass we've got coming up. We're showing about 38 minutes to sunset on world map. And so we'd be looking to do it about 20 minutes from now to get set up, and we just wanted to know for myself and Sonny and Brew what we should be working on the most.
Okay, CJ, we were just talking about that. You're reading our minds. We just sent another wiggle, and we were going to come up and ask you guys to take a look and let us know what you think. Give us a bay count, and we're thinking knock it off, but looking for your thoughts.
Megan, I've discussed it with pretty much the entire crew, and JR and Swanee and Pat. Sonny was here. Clay was helping to count and talk to Brew about it, and we concur with your assessment. And just kind of what we're thinking about that is that we had about 2.5 really good bays of retraction this morning after the fluff that Pat did yesterday with the grommets and the blankets, and then also what Swanee did with compressing the ends there. And it just seems like if we focused our efforts, the EVA guy up there, once you get the guy up there on the arm, moving back and forth went a lot quicker than we expected. It's quicker than the NDL. And we got really good views day and night. And I just think that we could be set up to get this done in about an hour and a half or 2 hours if we didn't encounter any other problems other than the grommet hang-ups.
CJ, we copy all. That sounds like a great plan. ISS and Atlantis on the big loop for an update on the SM computers.
Atlantis is here on the big loop. ISS is here on the big loop.
Hello, Clay and CJ. Basically, we wanted to update you on what we know about the computers on the Russian segment for just a couple of minutes, if now is an okay time.
Good for Atlantis. Okay.
Okay, as you know, the SM Central Computer and Terminal Computer have been off since earlier this morning, and we understand there's some troubleshooting planned on board for overnight. We have also learned that the power source for these computers is apparently very sensitive to any noise. The computers initially had problems around the time the first connections were made to the new truss. So there is some thought that even though there was no power on S3, S4 at the time, the physical connection of the return ground paths may provide a sneak circuit for noise. So we are developing right now a plan to use the scope meter to check both the 3A channel, which is the S4 truss, and the 4A channel, which is the P4 truss, for noise. Basically, this will involve accessing the aft end cones for you to get at the wires that we'll need you to check. And I'll have some more words on that here in just a second. But the other thing I wanted to tell you was that we think you're aware of how the SM computer status impacts our attitude control situation, but we want to be sure to tell you to ask us any questions if you have them. And to be clear, we're in a good config now, but we're sensitive to activities that may cause a loss of attitude control because it will be more difficult to recover without the SM computers being operational. I know that's a lot. How copy so far?
Atlantis copies all so far. Station as well.
Okay, the rest is just a couple of words for the station guys on some of the activities. We're still finishing up the procedure that we're going to ask you to do, but if you want to get started, you can start clearing off the Node 1 S4 and Node 1 P4 rack fronts so that you can rotate the ZSRs. We're also uplinking some words about getting out the scope meter and checking the batteries to be ready once we have that procedure ready to go.
Hi, this is Holly Hickman, Fox News Radio. We're talking to some intrepid and probably very tired shuttle astronaut crew members, starting with the commander, Rick Sturko. Sir, your team is performing well while handling a lot. You've got some station computer issues that could take a few days to fix, and tomorrow's a relatively improvised spacewalk. After years of training, how difficult is it when plans change?
Well, I think it's always going to be a challenge, and that's part of the training is to prepare the crew and the mission control team to deal with different challenges like have come up on this mission. You know, we do a lot of simulation in Houston, and it's almost never perfectly nominal. There's always some cases that are thrown at us to make, you know, they can't predict which emergencies and which malfunctions are going to happen, but it's very good training.
For Lee Archambault, you come from the same town as Eugene Cernan, the last man to walk on the moon. He inspired you to become an astronaut. What kind of space future do you see for the kids in Bellwood, Illinois you are inspiring, and how should they prepare?
Oh, well, Holly, thanks for asking that question. Best way for them to prepare is just to hopefully get interested in what we're doing up here building a space station. And if they are interested to stay stay smart in school, study hard with the math and sciences, and there's always a place for them at NASA. And then hopefully, we're going to transition from the space station to our endeavor to get back to the moon and then Mars and beyond. So the folks who are going to be going to the moon and Mars and beyond are those young kids who are in school right now in the junior high and high school. So if they're inspired by this, then have at it, because there's plenty of room for them as NASA goes back to back to the moon and then to Mars.
And speaking of the moon, when LEM crews, also Mr. Archambault, used to step on the moon, the command module pilot would take in the big picture. You're operating the robotic arm here while spacewalkers go outside. What is your big picture from inside?
Well, the big picture I have from inside is actually through a couple of about 3 color TV monitors, plus from my fellow crewmates looking outside the window of the space shuttle to help me see where that robotic arm is going. So I use a combination of cameras and actual views from folks looking out the window, because as you know, operating that arm here in the space station, there are no windows.
For Patrick Forrester, you are a retired Army colonel and a West Point man. How did the military prepare you for this job, and do you see space as a good way for young men and women to serve their country?
Well, the first part of that question, I think that being in the military teaches you just to adapt to different situations. You know, we have men and women all over the world right now in different situations, even than their training might have prepared them for. So I think flying in space is a lot like any type of operational mission in the military, not just the Army, but the others. So I think there's a lot of correlation, and all of that training, of course, helped prepare me for what we're doing now. And go ahead and give me the second part of that question.
Just if, basically you've answered it about it being a good way for young men and women to serve their country, but I'm also wondering about floating at the end of the 50-foot arm yesterday, leaning into that hot solar array. Maybe it's a little different practicing in the water versus floating around in space. How did that feel?
Well, first of all, that particular view I had from on top of the robotic arm that Brew was flying out at the end of the solar array was probably the most amazing that I've experienced. I had 2 spacewalks before, and at the time we were up on P6, which was about as far away as you could get from the shuttle. But this particular one, I was able to see all of the space station and the shuttle kind of down in the distance with the Earth below it. So pretty magnificent. It's one of those things that I always want to remember.
Your buddy did a good job driving there. For Steve Swanson, congratulations on your first spacewalk. Any advice to your 2 buddies who are also tackling that solar array tomorrow, and what made the biggest impression on you out there?
I'll start with the last one. The biggest impression is just the views. It's amazing. The experience was kind of overwhelming. Enjoyed it for Danny and JR on the solar array again. It's just listen to what Pat's going to tell them on the ground, and everybody had good advice, and just do what they say.
For the commander, you came here on the first assembly mission, and then you came back again 6 years ago. What connects this station to future missions to the moon and to Mars and to the vision for space exploration?
I think you're seeing great examples when we started off this interview, the difficulties that you mentioned and the challenges and the teamwork at NASA that have overcome those difficulties is really going to prepare us well when we go back to the moon. There's going to be challenges. It's the programs plan things, but things don't always go as planned, and it's the operations team that has to pick up the pieces when something doesn't work right and still get the mission accomplished. And I think the examples you cited are excellent and prove that NASA can do the job.
You think you can stand staying one more extra day if they decide to pull that possibility?
We'll be happy to do whatever we're asked to do, including stay one more day.
And one quick question about your team of spacewalkers who are going out tomorrow. You spoke a little bit about their fairly new spacewalk where they're going to be stapling that thermal blanket down. I know that they practice for contingencies, but are you confident in their abilities to be creative out there?
I'm confident in their ability to be creative, but they will be able to, I think you may have seen some of the materials that were sent up to us about the stapling, and then we had a practice session on board here, and all the tools were prepared today, and if you stick around for our highlights, you'll be able to see some video of those that work. So we're well prepared for the OMS pod repair tomorrow.
Commander, we've heard a lot about the computer problems on the Russian side. Can you update us? What's the latest on that?
They're still working through those problems, and I think there's some more troubleshooting that's going to be done on board by our crewmates, Sonny Williams and Clay Anderson, later on with the scope meter.
We're talking about a massive computer failure that's not ever happened before. The mission's been extended. Are these things just part of the job? How do you approach this?
As we were talking about earlier, you know, there's challenges that come up when you bring up new pieces of hardware or when computers are improved, and this is just to be expected that things are not always going to go well. Fortunately, we have a great operations team down in Mission Control and at the Johnson Space Center and over in Moscow at the SOUP that they're working together to decide what the best course of action is to troubleshoot it and get everything up 100% working order.
If you don't mind, gentlemen, I'd like to ask a personal question. I know you all have kids. Maybe, Lee, if you want to answer this, what kind of stories do you have for them? What do you tell them about your experiences?
Well, the experience I share with them is just basically what it feels like to live in space and experience zero gravity for an extended period of time. It's almost like you have to, you're a kid again, you have to start to learn how to walk again. Well, here you have to learn how to maneuver in zero gravity, and you're very clumsy at first, and I am, and I still am. You know, maneuvering as well as eating. The challenges that come when everything that you touch floats away if you don't hold it down. So I'll share with them the experiences. It is a lot of fun, but there's a lot of challenges just to get used to living, working, and operating in a zero gravity environment.
What do you plan to use to fix this thermal blanket, and how are you going to go about that repair on the shuttle? Lee Archambault, you may as well answer that.
This is Pat. I'm going to go ahead and answer that. I'm the IV or the crew member that's inside talking to the two spacewalkers, and we've got a set of procedures at the ground put together, improvising with some of the tools that were already on board the station. In fact, they're using a surgical staple, and Danny will leave us on the robotic arm, and we will take him out to the location, and he will staple that blanket down and then pin it in place, and we feel that'll be a great repair and bring Atlantis home safely.
Steve Swanson, your first space flight has been a memorable one, maybe not for all of the reasons you expected it would be, but how's the space been for you, your impressions of it so far on this first flight?
It's been great. Impressions are everything it's been talked about and lived up to is all my expectations. I've enjoyed it. It's been more, I think, one of the best things about it, though, is overcoming the problems. So it's not really always a negative to have problems. It'd be nice maybe not to have them, but when you get to succeed, and even though you had a difficult mission, I think that's a great sense of satisfaction.
You had 9 years of training before your first space flight. It looks as though you're taking everything you've learned in that 9 years and putting it to good use, I would imagine, over the course of this space flight.
Yeah, we've all trained a long time for this, and I think all of us feel that same way, that the training has not been in vain. It's good to be able to do this and accomplish the mission.
I know you brought Ralphie the Buffalo and a flag up there from the University of Colorado, which has now sent 18 astronauts into space. What do you think makes CU such a great incubator for astronauts?
I think it's location. Everybody likes to go there. It's a wonderful place.
How did that first spacewalk that you went on compare to what you'd imagined it would be like in your training?
It was was one way similar to the pool. The tasks are very similar, but what you don't get is a view. When you're working away, and all of a sudden you look up and you see the Earth going by real quickly, and all the views can get kind of overwhelming. You have to stop and take a look at it for a while, and then get back to your task. But I think that was the biggest difference, is just that view you can see.
This is Mission Control Houston. We're continuing to receive downlink television pictures from inside the Unity module of the International Space Station as Sunny Williams and a couple of her colleagues work through some diagnostic steps using a scope meter and a current probe to take a look at cables inside the Unity module that are used to transfer power from the American to the Russian segment of the space station. One of the leading candidates for what might be going wrong with the Russian navigation computer systems is that there may be some problem with the power that they're receiving through the American side of the space station, or some sort of electromagnetic interference that's associated with the recent connections to the S3, S4 truck structure. And so the crew members are working with a scope meter and a probe, going through several steps in association with the folks on the ground, the operations support officer and the Falcon officer in the space station flight control room, to see if they can locate any of these power cables that have excess noise on them.
Okay, Houston, here's the morning of Flight Day 7, and you can see JR is getting the EVA repair information out of the printer. I hopped on the bike during the post-sleep time frame, got a little exercise in. It's good to do this, and then you can get cleaned up and you're all set for the day. Brew is doing some routine maintenance activities in the WCS. And, of course, we have to maintain the entire shuttle and do what the scheduled activities are. So he got that all taken care of. Deanie is managing some of the videotapes for Photo TV. You can see them floating. It's a big organizational job, and he's doing a great job at it. I've had a lot of help checking things over, backing me up on the paperwork. Here's Bruce taking a look at the flight plan, and Pat is also probably at this time organizing all the messages and making sure everybody knows what they need to do to carry out the plan of the day. Okay, the first thing we did was the solar array retract. I did this with Sunny Williams. Here she's setting up the computer on the aft flight deck. She is the one sending the commands today to retract the solar array and then making the calls on the big loop to abort it. I'm looking out the windows with the binoculars. See, we got a camera set up, and we're all communicating on several loops here to make sure this went smoothly. When we paused for a moment, I was able to snap some photos, and we were able to downlink them to the ground using the computer setup that Swanee has going. Here you'll see some of the motion. We retracted one bay at a time. The first couple of attempts were very successful. We had a good snapback, which you may be able to see a whole wave kind of went up the arrays and popped everything loose. And then we ran into a little holdup where we had a little guide wire sticking out that went slack, and then it corrected itself, and we were able to retract just a little more. We're expecting big things tomorrow during the EVA. Here's Clay and Brew. We're backing us up over the RWS with camera view support, and then also sending backup abort commands on the PCS when we stopped.
Hey, this is Clay Anderson, and here JR is getting ready to set up for the EVA that they're going to do tomorrow. They had to prepare a lot of special type of items that they want to take out with them to allow them to do the repair to the insulation on the ohms pot. And that's what JR is doing right here, is setting up his tools for tomorrow and having a little fun while he does it. And this is Sunny Williams. She's doing a little bit of work to help for the EVA as well by doing some battery recharging. Every time we go out with the suits, we have to bring them back in and then recharge the batteries for use later. And here I'm in a tool flurry with stuff getting ready for our oxygen generation system. And what that's going to do is provide O2 for the station on the U.S. side, and we're going to have to vent the hydrogen overboard that we create. So one of the things I'm doing is opening up the line to test it for pressure, such that when JR goes outside and opens up the valve on the outside of the station, we can vent. Okay, this is Brew, and in preparation for tomorrow's EVA, Danny's going to be flying on a space shuttle robotic arm that Steve Swanson and myself will be operating. In preparation for that, both Swanee and myself reviewed on a DUG display the exact trajectory that the space shuttle robotic arm will be taking as we pick up Danny and bring him back to the OMS pod for the repairs. And here I am fighting with those tools again, trying to get the valves, all the connections hooked up so that we could open the line and check the pressure and make sure that there were no leaks. Fortunately for us, we were successful, and the part that goes from the inside of the station to the outside is leak-free. The day before spacewalk is just about as busy as the spacewalk itself. There's a lot of effort that goes into preparing the suits. Because we have two spacewalk teams, we had to take the suits out from the previous team and put the ones in for JR and Danny's walk tomorrow. More preparation with JR preparing tools. The tools he is using that he's modified is actually a surgeon stapler. And he has prepared it so that it's got a tether on it and can be used outside. We do some photo documentation of those to send back to the ground to make sure that they were prepared properly. With a lot of the preparation done on the ground and a review of the procedures, it was time to tag up with the ground. This was a chance for us to interface with Team 4 that has really worked tirelessly preparing for this unexpected task of repairing the OMS pod. That involves everyone from flight director down to someone in each discipline. They run the procedures and prepare the procedures. If necessary, get in the MBL. And once we were able to hear their words on it, review the procedures again, we felt like we were ready to go. They actually sent up some videos that we could watch of them doing the work down there, which were helpful. Only so much can be described with words and with pictures, and the videos that they sent up helped as Danny then began to prepare to do this task. Once we had all the instruction from the ground, we got a team together that would be doing all the work on orbit. That includes the spacewalkers, myself, who will be reading the procedures, and then our two robotics operators, Lee Archambault and Steve Swanson, just to make sure that we knew each other's role and exactly what we were going to do. This isn't one that we were able to practice on the ground, and yet a combination of the work that was done by Team 4 and the time we spent today here, for example, is Danny practicing the staplers, using the stapler to put together two pieces of foam that represented the tile. This is the first time he'd ever had a chance to even hold this thing, and really did a great job. We're hoping that the repair will go just as well tomorrow. There's a SBS target that was taken off the station in the first EVA several days ago. Besides using the stapler, there's also a series of pins that are going to be used to secure the blanket against the tile, just to ensure that as the aircraft goes through the airflow as we return to Earth, that it does not blow back. And with that, it was the end of our day. The sun is saying goodbye, and we're looking forward to a big day tomorrow.